Today we have heard a lot about the different infrastructures. We have heard about large data sets and people doing compute on those resources with those data sets. And what I want to show you is one way that you can use those resources in a kind of a little bit more formal way. And so this is Pegasus itself. It's a workflow engine. I'm going to talk about what that is. I'm going to talk about a specific instance called ACCESS Pegasus that we have offering as part of the ACCESS program, but it's also usable in AIRE and your campus cluster and so on. So a common problem that we see with our users is the scripting trap, right? So people, they want to do some compute, they start writing a script, and pretty quickly that script becomes a bigger script, and it becomes, maybe there's some hard coding in there, it's locked into your environment, your laptop, your cluster, or so on. And at some point you have invested so much time into the script that now it's really hard to move away from it, right? What we suggest you do is that you look at the workflow engine earlier, sooner rather than later, and use a more formal way of describing that computation. And I'm going to describe then, why we think this is a really good idea. As I said, the workflow in question here is called Pegasus WMS for the workflow management system. It's been around for a long time. It's an open source product, so you can install it on your cluster or your laptop and so on. But what I'm talking about here is this hosted environment where you can log in and do everything via a graphical or web interface. You can think about this as almost like a little bit of an overlay of the compute resources. There's a different interface that you use to submit jobs, and then they flow to the available resources. The web interface, as I said, it's a web interface. There's two components to it. One is called Open on Demand, and that is a pretty standard web interface for clusters, for HPC machines. It handles things like authentication and file management. You can upload and download files and so on. And you can start applications. So the application that we start in our case is Jupyter. So you get a notebook, and from that notebook, then you can manage your computation. You can do light data transforms and so on, data find, create the workflow, and manage the workflow. When I'm talking about a workflow here, I'm talking about a DAG, a directed acyclic graph. And so the idea here, obviously it will be different for different sciences, but the point is that you have a set of tasks that you need to do. Those tasks are the nodes in that graph, and the edges is a dependency between those jobs or those tasks. So for example, you have a task that produces a file, and then there's another task that consumes that file. Then there's an edge between those, indicating that relationship. The other thing that happens here, right, is that if you declare your computation like this, is that the workflow engine can parallelize your computation for you. We can know from just looking at the graph where tasks can run in parallel, and we can then optimize this for the resource that you're trying to run the workflow on. Our workflows are defined using an API. So you see up here, there's from Pegasus API import star, and then in this API we describe the workflow in using files and jobs. The files is an important part of Pegasus. Not only do we track the tasks, but we track the data, and I'll explain that a little bit more later. But in this case, we have a simple example where we just want to download a web page. So we're using the curl command in the first job. Then we pass that file, the output of curl, into the second job, which is a word count, or WC command. And then at the bottom, you will see how we have, we're adding the jobs to the workflow, and then we add dependencies. So we explicitly say, what's the parent-child relationship between those tasks. In this case, it wouldn't even you don't even need that, because Pegasus can look at that file and say, hey, I see where that file is getting generated. I see where that file is getting used. And it can infer the relationship that way. So in this case, we can be explicit. We can say, okay, there's actually a dependency, but you don't have to. Now, the code here, right? Like when we talked about defining workflows in an API over the years, we have had feedback like, why aren't you using a graphical user interface, right? Like I like to drag and drop, and I like to see the result immediately. But we have pushed back on that, and mostly because the scale of some of these workflows, if you have hundreds of thousands or millions of tasks, you just can't visualize it in a graphical user interface. But it turns out that now this is actually an advantage to us, because we can now use a coding tool like Cloud Code or something to generate these workflows. And I'm going to show you two little tricks how to make this easier. But it's pretty simple, right? We want to describe our science. We want to give the coding tool some context about what is our style, what do we want the workflow to kind of look like. We do the processing. And then number 4 here, the human in the loop, is a little bit unusual, right? Because if you just, let's say you go to YouTube and look at vibe coding tutorials, a big part of that is to have automatic testing, right? Because that will means that the tool could iterate and kind of improve. The problem with doing that, and workflow specifically, but I would think this is kind of a general science problem, right, is that like for simple coding tasks, writing a unit test is fine. But doing that for either like a large workflow that takes a long time to run, or for just a science problem, right? Like how can the LLM tell if that science result is valid or not? So a lot of the times when we do this, we have a human in the loops, we let it iterate once, we validate it, by hand, and then we let the LLM go again. So the second hint here how to do this is grounding the query into an existing workflow. And if you leave this out, let's say that you just say, hey, create this workflow for me. There's plenty of stuff online, there's plenty of examples and stuff, but you don't really know what style it will be. It might be picking up stuff from an example that you're not really interested in. So what we recommend is that you find a workflow that you kind of like. It's maybe because it's in your field, or maybe it's because like you think they have done a really good job, or it's targeting a resource that you want to target. And then you ground it. So what you're saying is, in the context, say I'm building a workflow to analyze some data. Then grounding, you say, here is a workflow, and I want the new one to look similar to this, right? I want to use this style, I want to use similar syntax, and so on. And that alone just makes it so much, the results so much better. So that's something to keep in mind. I don't think this is specific to Pegasus and workflows either, but it's really obvious when you do this. So a couple of more Pegasus features. One is this automated data management. Remember when we looked at the code and I said, hey, we have to declare all the files that we're using? Well, the reason for that is that Pegasus tracks all the data, and not only tracks it, but manages it. So we can do automatic data transfers, automatic data placement. We can put jobs to where data is, and so on. And pretty much all the jobs in the workflow will have some kind of data management associated with it. A lot of the time, that means staging some data, doing some compute, staging some more data, and then maybe cleaning up. So there's a lot of this stuff that you get for, built into the workflow engine. Another thing that the workflow engine does for you is providing some resilience. So examples of this is if you have a task in a workflow that fails, the workflow engine in this case will just retry it a couple of times. Again, it's surprisingly how often that works, right? Like maybe there was a little blip, maybe you landed on a bad node, whatever. but trying the job again, that works a lot of times. If the workflow gets into a place where it can't make more progress, like it's exhausted its retries, it will write that state, and it stops there, and it will allow you to start from that location later, right? That state. So you don't have to redo computations. And a common example of this, let's say that you are running on your favorite campus cluster, they go down for maintenance for a day, and you can't make any progress that day. The workflow will start, and then when the site comes back up and the cluster comes back up, you just start it over again, and it will just keep going. Similarly with checkpointing, this is you can think about you have a machine learning training, and you iterate over so many iterations. You write state, and then the workflow can then pick that up and keep track of that, so that if that gets interrupted, if the machine learning gets interrupted at some point, we'll only back up to the last checkpoint and start from there. And then the workflow engine also comes with some debugging tools. We have one called Pegasus Analyzer that will pinpoint failures. And this is important, especially for large workflows, because you don't want to go through logs or anything like that. You just want to know where the error is, and Pegasus Analyzer will do that. In the next generation of the next version of Pegasus, Analyzer has some AI capabilities, so it will try to do a root cause analysis of the failure as well, and kind of help you along debugging that way. So I said that Pegasus provides a little bit of an abstraction to these resources. We provide connectors to a lot of the different resources we've been talking about here today. Access resources, NAIRE resources, the path facility, commercial clouds, academic clouds like Jetstream, and pretty much any HPC resource. So if you want to split your jobs between running on your campus resource and Access or something like that, that's totally doable with this system. We also have a test pool, and that's one we will be using if we get to the demo part. This is a little bit of, think about it as a free tier. Like you can come in, you can develop workflows, and you can test stuff, play with things, use it in the classroom without having an allocation. And then if you need more than that, then you go and get an allocation and do all that steps. An important feature that's built into workflow engine is collecting of provenance data. So every task that we run, we collect some metadata about it. It's about data location. We check some of the data so we know what data we did compute on, software versions, different parameters, and execution statistics like performance and environment. And so this is important because you can come back and verify, what happened and what compute took place in the workflow. This provenance data, together with the fact that we have a workflow defined in a formal way that we can share and collaborate on, checks both the verifiable and the reproducible checkboxes here. So it's a really easy way to kind of share the workflow, share the results, and publish the results. So here's an example of a workflow. This is not the most advanced workflow we have. It's not the most fun example. But what it is, it's a good example of what I started this talk about with going from a local little script, something that Connor did on his laptop, and then going to, how do I actually run this at a bigger scale? So you see the steps here, the little red steps, the simulation, the M-tuple, and the data validation. This is what Connor had created, and it ran fine. The problem was that he needed to do it 590,000 times. And if he did that the script way, well, that would be 15 years of compute, and he wanted to graduate, so that wasn't really a good idea. But doing that, then you see how the workflow then just becomes basically just a bunch of mirrors of these 3 tasks, and we get it down to 4 hours. So you went from maybe not being able to graduate to, hey, this is something I can run every day and iterate on and get results on. Another example, it's not, I'm not going to talk in detail about it, but I want to talk about it in a sense of that this is a very typical workflow problem. This is about the dark matter search. It has a detector in Italy that produces data, then that data flows to different collaborators all over the world. And so Pegasus, with the data management codes and functionalities, can grab that data, run the workflow anywhere, and pull the data in. It's also that enables that sharing, right, with all those collaborators. They can collaborate on the same workflow and keep it in that sense. And the red box is an example of that provenance data I talked about, where we can pull out some reports about how did the workflow do. So, for example, down here we have that the workflow wall time was 5 hours and cumulative was 136 days of compute. So that's also another scaling up example, but the biggest part here is the data management and the workflow sharing. And last, I wanted to have a slide pointing back to what Nira was saying about cybers. And so Event Horizon Telescope, they had data in the Cybers data store, and the compute took place on Open Science Grid. That's what was the PATH facility today. And what it shows is just a very simple, hey, I'm going to pull some data, I'm going to do some compute, and I'm going to put data back. And I'm going to do it a lot of times, right? So again, a very common approach is to have a disconnected place where you put your data and where you do the compute. It does not have to be the same place. It can be, but it does not have to be the same place. Let me see what time. Right. So on this slide, I'm just showing a few examples. I'm going to point you to them in the ACCESS Pegasus instance here in a second. But what I wanted to show you is that there are some example workflows available to you that you can use either for the grounding step that we talked about in the vibe coding, or you can use them for just, hey, so how did other people implement, for example, simple machine learning and training and inference, right? So lung segmentation, ultrasound, and mask detection, those are all machine learning. And there's a variant calling, which is bioinformatics pipeline, very typical. And in the bottom, I have an LLM RAG, which is part of the tutorial. I don't think we'll actually be able to have time to run that one, but that's one of the ones I'll point you to here in a slide or two. Yeah, so well, I'll talk about the RAG. What's different about this workflow, what's different about this approach than compared to what a lot of the stuff I've heard today, is that this is a self-contained LLM that we put on compute nodes, and we do some processing, and then we tear it down again, right? So this doesn't go out to like a commercial LLM or anything like that. A big reason for this is maybe you have data privacy, right? Maybe you're processing stuff that shouldn't go to a commercial LLM, but it could also be that you have a lot of stuff to process and you want a lot of instances of this, so it's a way of parallelizing it as well. So this example is using a Mistral LLM. It's a pretty standard stack, lang chain, and chroma vector store. And the example is just a public domain book that we feed in. We add that to the LLM. We have RAG, and then we can make queries against that extended database. So ACCESS Pegasus, I mentioned a few times. Here is the URL, pegasusaccessci.org. This is part of the ACCESS program. It's part of ACCESS support, and that's hosted version I was telling you about. Anybody with an ACCESS account can log in here. you do not need an allocation. So if you log in and you do one of the quick starts and one of the tutorials or one of the example workflows, that will run on that test pool, so you don't need the allocation for that. But if you graduate from that and you say, hey, I want to, now I have a bigger problem, I want to run on an AIRE resource or something like that, that's easy to do, to just add in and saying, I'm just going to add that to my computational pool and extend it like that. Similarly with if you have a lab machine or if you have campus cluster, just bring them in and do the compute from ACCESS ACCESS Pegasus. It's pretty simple. We log in, we launch, and we run. And I'm going to show you that. I'm not going to run anything, but I am going to navigate in there and show you what it looks like. So I'm going to do that a little bit quick. I have a few minutes at least. So Pegasus, accessci.org. All right. What it did do there that you did not see was CI logon. Right? That means that it was calling out to your university credential. It mapped me to my ACCESS account and logged me in that way. So again, for anybody with ACCESS accounts, this should work. We'll start a notebook, and I'll just show you with some navigation thing. We'll launch that notebook. It'll take a second. Okay. I love this screen. It's so easy to, I don't even have to zoom in or anything. Maybe I'll zoom in a little bit. All right, so what we see here, when you log in, everybody will have these ACCESS Pegasus examples. This is pre-populated for you. If you look in this folder, you will see a set of number directories. There's 8 of them. These are the tutorials. That they are self-guided, and we can start one here in a second. But after that, we have those example workflows as mentioned before. So if we took an AI, for example, you will see the log segmentation and all that stuff. These are all self-described. We can go to Orchesound and look at that notebook. Right. And it will have description of the workflow, the code, and everything that need the data that you need and all that stuff. Let me just bounce back, and I will show you. I'll start a workflow and show you how it looks like. So this is number 1, 01, quick start. And again, it will explain. There's even a little video in there. It will explain what the workflow we're trying to run. So this is a hello world workflow. Where there's an input file, intermediate file, and output file. And the way that these workflows, the way that these Jupyter Notebooks work is you just step through them, right? So you just click run, and then run, and here's the code that generates the workflow. Remember we had the files and the jobs and so on. So we run that, and we get some feedback saying, okay, I created this. We can get a visualization of that workflow. So again, very simple, and we can run it. So submit, and off it goes. So again, this always works. You don't have to find any resource to run it. It just works on that test pool. So I think that's where I'm going to stop. Any questions about that?
Can you say after that, how do you create your own workflow?
How do you create your own workflow? Well, that we go back to use AI to create your own workflow.
Yeah, but
that's one.
In ACCESS, do you start using Jupyter Notebook?
You can, right? So the easiest one is obviously just take a notebook, make modifications, and save it. Save it as a new notebook. So you have space on this machine to do that. It's all the, but it's obviously easiest to start with something like this. I'm saying, okay, my science code is something else. I'm going to change it here. I mean, that's the easiest thing to do. I'm going to leave you with this slide, though, because everybody else has been talking about office hours and so on. So my team, have funding to help you out with your workflows. Don't be shy, come and talk to us. We have Slack channel, we have mailing lists, we run office hours once a week on Fridays at 11 a.m. Pacific time. The first Friday of the month, we do a tutorial. That's also recorded on YouTube, obviously. And we have tutorials being scheduled probably for February or March. And you will find them on the Access Support calendar. They will pop up there and you get notifications. And obviously our website. So, yeah, thank you, and I'll take any questions.